There are certain fractions that you pretty much need to have memorized in decimal form because we use them so often. The first one is 1/2. You should have that memorized as 0.5. When 3 is in the decimal and you have 1/3, that becomes 0. Repeating 3's. Likewise, 2/3 is equal to 0. Repeating 6's. You should have your fractions with 4 in the denominator memorized. 1/4 is equal to 0.25. And you're used to, in money, talking about 1/4 being 25 cents, so that should be not too hard to memorize. Now, 2/4 is the same as 1/2, and that is already on our list. So I'll move on to 3/4, which is equal to 0.75. You should have the denominators of 5 memorized. 1/5 is 0.2. 2/5 is 0.4. 3/5 is 0.6. And 4/5 is equal to 0.8. Probably the other ones that you want to have memorized are the ones that have 8 in the denominator. 1/8 is equal to 0.125. 2/8 is 1/4. It's already on our list. 3/8 is equal to 0.375. 5/8 is equal to 0.625. Notice how I added 0.5 from the row above here. And 7/8 is equal to 0.875. These show up often enough that they should be memorized, if not memorized, highly recognized. If a fraction is not on that list and you need to convert it from fractional form to decimal form, then you've got to do long division. Let's say we have 3/40. If you want that in decimal form, you will have to do long division. 3 divided by 40. 40 does not go into 3, so we'll put a decimal after it and put in a couple zeros. 40 does not go into 30, so the answer is no. 40 goes into 300, however, 7 times. 7 times 40 is 280. We could then subtract and get 20. We'll have to put another 0 in, which we bring down. And 40 goes into 200 5 times exactly, so there's no repeating decimal. We're done. Now, when it comes to starting with a decimal and converting to a fraction, let's say we have 0.374. We would first pronounce that number. This 4 falls in the thousandths column, so I would write that as 374 thousandths. Then I would begin the reducing process. These are both even, so I can divide each by 2. I know the denominator very easily will become 500, but with that numerator I may have to do some long division. I'm going to end up getting 187. Now 187 is not divisible by 2 or 3 or 5 or 10 or 6 or any of the numbers, and pretty much it's not going to be broken down. This is in reduced form. But if it could be broken down, we would. When we are plotting decimals on the number line, we either have to have a good intuitive sense or we need to convert to a fraction. This 2.3 is the same as 2 3/10. And we know that when we're dealing with fractions, we need to split our interval, in this case, into 10 equal parts. I'm just going to start by splitting it in half, and then I'm going to hopefully more easily split this into 10 equal parts. And we would move 3 of those 10 parts to the right of the 2 and have this point plotted now at 2 3/10. Other people just like to eyeball it. They know that 2.5 stands for 2.5, and they just kind of go a smidgen to the left of that and just eyeball where that 2.3 would fall. If you have a repeating decimal such as 0.6, repeating, you pretty much need to know that its fractional equivalent is 2/3, and that we would split this interval here up into 3 parts and plot that point right there in 2 of those 3 parts between 0 and 1. Now if you wanted to just eyeball it and say 0.6 is a little bit right to the right of 0.5 and say 0.5 is right here, so we're a little bit to the right of it, you can do it that way. Usually you're not asked for super precision when you are doing this. If you are, however, ordering numbers that you are plotting and you need to make a comparison, that's where it comes down to looking at the decimal equivalents and going with a position by position analysis to determine which is smallest and which is largest, as we did in a previous video.